So now I'm going to do the second of 3 videos in which I show how to do some spatial data applications in R. I'm building on the first video where I opened some shapefiles with points, lines, and polygons, where I showed Milwaukee robberies in 2014 as points, the city line as a line file, and then census block groups as a polygon file. And here I'm going to build on that, but what I'm going to do is I'm going to do what's the equivalent of a spatial join in GIS software. I'm going to overlay the robberies onto block groups to see which block groups have the highest number of robberies. But because you'd expect large areas to have more crime, I'm going to normalize it by land area. Now earlier I showed that land is going to be a problem because it's a string file. We're going to have to convert it to a numeric file. And there's a couple problems as we go along the way, and I kind of note that it's in lines 17 and 46 as well as 47. Here in your file I hid it like this, but here I have already unhid it. And the reason is because in the third video, if I kind of redo it to get to that point, the file won't run if it's got the errors. So I hide them, and you can ignore them if you want to, but they're hidden so that they'll run on the third video. Now one weird thing is that since the first video, my jump drive is now read as I, right? So I'm leaving that, but what I had to do, and it might not apply to you if it's the same for all, but I had to change it in my first file too. So if it doesn't run, you might have to do the same thing. But for here, I changed it to I just to match what my computer is doing. And so I'm now reading off the I file, and I set the working directory here, and then again, I unhid those 2 lines just now, right? So before I begin, I want to say you can bulk download files for a number of different types of work. It's the install. You can use CTV, you install it and run it, and then install .views, and then spatial gives you a large number of spatial files that we're really not going to use, and it doesn't include GIS tools, I don't believe. So you wind up installing extra anyway. So rather than do the time-consuming process, I didn't even really put it in, but it is something you could do. And there's also a time series one and some other applications too, and so it's kind of like a bulk download for packages. So put that in there, but I'm not going to do it because we have the files we need. And so I am going to get to where we are by running the first file that we have. All right, so it's going through exactly what I did on the first video behind the scenes, and I'm going to, remember, this kills your graphic. So it's going to do everything, and it's opening up all the files, it's opening all the packages, and then I'm going to make sure that I set the working directory to I. So here it's opening the shape files as before. Remember, land area is a string. Here's the histogram, here's the robberies as before, and then I kill that, right? So now we're ready to begin. And like I say, check lines 17 and 46. I put some errors that we're going to fix. So first one of those is we're going to begin by overlaying using the over function, over command. And so over, we're going to have points on 2 polygons. All right, so it's going to run all the robberies onto this, but this is the problem we get. And this is weird because I fixed the projections in the last video, but it's giving me a projection problem now, and projections are just always tricky. So I need to make the coordinate reference system the same. So remember, I am going to take, first of all, I'll show you those coordinates. All right? And the weird thing is it's this NAD83 and WGS84. This is the one difference between the two. So I'm going to take robberies projection and I'm going to put it into data's projection. In other words, I'm going to rewrite data's projection so that is robberies, right? And I'm going to redo this. I'm going to call it count, right? So it's the count of robberies per polygon, right? So every block group gets a number of robberies. It should be a whole number, all right? And it should be the number that occurred, right? So here I'm going to look at the head, all right? And you actually do not see the count in here, all right? It's got all the data from before. But if we make a table, and notice that count has a number of sub things, right? It's going to be the table. One of the headers will be GeoID, which is the unique identifier for each block group. Here we have for all our block groups. For example, in this block group there were 5. In the bottom last one there were 9 robberies in 2014. Right? So I'm going to extract just the number. So I'm going to make it as numeric, and that's something that needs to be done in cases. And again, I add it because when I try it, I do what makes it work, and I put the stuff that works here. So if it's an integer or if it's text, it has to be converted to numeric. And I take my table. Remember, this is the inside, all right? And then I just strip out the numeric part of it, and it's simply the count. You can see there's, some have 28 and some have 7 and some have 0. All right, and now I'm going to append it. So in the data part, remember this is a data slot. I'm going to make a new column, right, which didn't exist before, rob count, and that's going to be what was here. So I took this and I repeated it. These numbers are going to go here. And one thing that I like about using this method, you can see that it's tied to GeoID. Sometimes adding a column to another, it does it in random order or numeric order. You could be adding what you think is column 10, and the robberies from column 400 show up simply because there's nothing linking each one. But if these are both linked to GeoID, they're both linked to the same block group. So I'm going to add that as a column. All right, and then always check your results, and we're going to see that there's a new rob count here, right? So you can see that they're added. Now, so we have it added onto our data file. Okay, now you can count, but I always check the column names as one way that you can tell that this is 6, 7, 8, 9. Rob count is column 10. So if we need a 10, if we need to put in the number, we know to put in 10. All right, now we're going to make a choropleth map like we before, and like we did in the first video, we're going to make breaks and we're going to make colors. So RC is rob count. I just called it that. That's my variable that I'm separating out. So I'm making just a one single variable here, and that's data rob count. And I'm going to make my breaks. And I've got my class intervals, which are already open, data, slot data, column 10. And we're doing 8 breaks for 9 groups, and we're using those Jenks natural breaks. And here we go. Actually, I don't need to repeat that. Although if you redo it, nothing bad will happen. But it's better than doing it 0 times. So now I've got breaks too. We can actually look at that just to make sure. You can run that. You can see that this is where they break up in terms of the numbers. All right, so there's a lot of zeros, and then the gap from 0 to 1 is large, and then of course there's a huge amount up here. Now, choropleth map, we're going to do the same command as before. We're using data. Our variable is RC, or the robbery count. Shading is breaks 2 with the colors. And the colors, remember, we ran it the first time, and we ran it now. We're going to use that same white to black scale, and we're going to say number of Milwaukee robberies 2014. Remember, Maine is your title. And then we're going to add true. We're going to superimpose the city line in black with a thick line, a thick solid line. All right. Now this is not actually going to be the greatest map, and what we're going to do is normalize it, because if you look here on the northwest side, there are a lot of dark colored block groups because they're big, larger area. It's less population actually, but it's more area down here by the airport and so forth. So on the edges of town, you see a lot of robberies simply, and that might be a function of size. Right? So we're going to get density per unit of land area. Now in my work, I believe the paper I published related to this, you could do it divided by population, right? But I didn't include that there. I'm going to do it based on land area. So I've got my data, right? This is my big file, and then the slot, the subgroup is the data slot, and then the specific column is robdens. And then I am going to, this is new, this does not exist, but what I'm going to do is I'm going to make it as rob count divided by the same thing for a land. But a land, remember I said, is a string. So I'm going to do this, and it won't work. Right? Not meaningful. You cannot divide a number by letters. Right? And I'm going to take this off, right, so it doesn't mess up my column. Right? It'll actually add a column, and it'll change everything I need to do from here. So I'm going to turn the integer into numeric numbers. Now you can think you can just do as numeric, but it doesn't make the correct values. Right? So you can look at this. This is the head here, and it's in, I believe it's in meters or square meters. It's very large numbers. But if I just do as numeric, these numbers are completely different, right? And I'm not exactly sure why that is. And rather than going around and fix it, I'm just going to do this as a workaround. I'm going to make a new one called aland2, okay? And that is going to be as numeric, but first I make it characters first, then as numeric. And if I do it here, it should work. And if you look at aland2, it's, the first value is about 410,000, and it's exactly the same over both. Okay, so I'm pretty confident that's a good workaround. I'm not sure exactly what the underlying issue is, but if you see the problem, you can easily come up with one line of code that fixes your problems. Right? So I'm going to check my histograms. One for rob density and one for robbery count. Rob density is clearly there's a lot of block groups with 0, right? And then it sort of trails off. It's skewed. Rob count is pretty much the same, although there's probably a couple high values over here. I'll always look at the distribution of your data. And again, always look at your column position. Rob density should be column 12, right? And again, I added a column and deleted it. If I saw that it was still there and something bumped it over to 13, I could go in right now and change it as I'm talking. It would fix everything, right? What you don't want to have happen is just automate everything. You make one mistake and all your results are wrong because you're pulling from the wrong column. But this is correct, and that's one reason why I undid. And it's also one reason why I hid the things for the next video. All right, so I've got my... I'm going to really care about robbery density, which is 12. And so now I'm going to make some breaks. So I take class intervals, data, and the way you do it here is the slot, column 12, and And again, it's 8 breaks for 8 breaks for 9 groups, and I'm using Jenks natural breaks. And so I'm going to make a thing called breaks 3. It should appear here. You can see it. It's got the values as well. Now we're going to make the choropleth map for density just like we did before, but the only thing is I've got RD for Rob density. And so I just change it, and I make sure I got my breaks updated, and then I've got density of Milwaukee robberies 2014. Same thing with the city line. And if I plot that, it looks okay. I mean, it's got near north side, near south side. It's a little too dark for me. I didn't really go in and make it lighter. You'd think there'd be a lot more like white shaded ones. You could play around with the breaks. You could make your own breaks. You could actually make, you could make a column before something, and then you could actually put in the numbers you want. As long as you separate it by columns, you can make your own thing. You don't have to have a program pick it for you. So if I wanted something to equal 0, I could go in and change my breaks. But for now, I just leave it as that, because in the third video we're gonna do some more statistical stuff. So plotting the density is a good start, but it's not going to be our final product. Right. So finally, I'm going to print to JPEG as I've been doing. MKE Rob Dense. Right. That's just what I chose it. It's going to be a 9 by 9 inch. Right. Width and height of both 9 units inches, 300 dots per inch. And then my choropleth was just from the GIS tools set of functions. The package. Then you got SP's data, right? That's what we're using. Then RD shading is breaks 3, which we just made colors as colors, and then we have a nice title listed as main, and then we plot the city line as a superimpose. And if you see here, it does not appear in our window here because it appears up here, right? So if we look at it, we can see here's what we made. All right, and again, there's a lot of tweaking we could do. I would probably go in and make a break at 0 and have a lot more white shaded, but for our purposes, it looks fine. Right, and again, I always use black and white because if you print in black and white, it's a little bit easier to see if you don't use color. All right, so that's our final project. So what we did here, just to kind of recap, is we overlaid, which is like a spatial join. We attributed those points to the polygons, how many robberies per block group, normalized by land area, and then made a choropleth map that showed those relative densities. Right. Along the way, we came up with 2 problems. One was projections, and one was a string variable, which we fixed. But end result is that we have a variable of the density of robberies in our data set.